Hi everyone, it's Mrs. Schmidt here today to talk to you about keeping things simple. We're going to learn how to simplify your fractions to lowest terms. Don't worry, we're going to use what you already know to make it super simple and easy to learn. So let's start off by looking at this example. If you see 3/4 and you want to know how to make an equivalent fraction over 20, what do? That's right, you multiply by a quantity of 1 to make an equivalent fraction. What would you multiply 4 by to get to 20? Oh yeah, you multiply 5. So you know you have to do the same thing to the top and the bottom. 3 times 5 equals what? That equals 15. So you know 3/4 equals 15/20. If 3/4 means the same thing as 15/20, why don't we just say 15/20 all the time? Well, because it's not as simple. 3/4 is easier to understand in our mind. We can picture how much of the quantity has actually been used. 3 pieces out of the 4, that's a lot. But if you try to imagine 15 out of 20, it's not as clear. Let's take a look at the next page where there's a lot of examples of this. In each row below, there are 5 squares with the same part shaded. Write the fraction for the shaded part below each square. The 5 fractions are equal fractions. The fraction in simplest form is the fraction that uses the smallest numbers. Circle the fraction in simplest form. All right, so let's change colors here. We can see that the amount that's shaded here is 2/4. I have the same exact quantity shaded, but my square, is divided only into 2 parts. So instead of calling it 2/4, we're calling it 1/2. Here, this square has been divided into 16 parts. And we see that we have 8 shaded. But notice the amount of green is the same in each quantity. Over here, we have 8 parts to our whole, and 4 have been shaded. And over here, we have 1, 2, 3, we have 10 parts, and only 5 have been shaded. So again, notice all of these squares have the same quantity shaded, but they gave it a nickname. They gave it a different equivalent name. So 2/4 is equal to 1/2, which is equal to 8/16, which is equal to 4/8, which is equal to 5/10. But what's the most simple way to express that quantity? That would be 1/2. You're not going to go to your waiter and just say, I'd like the you pick 2. I'd like 8/16 of a sandwich, and I'd like the Caesar salad, please. No, they would look at you like you were crazy. You just say, I'd like half a sandwich, because half is a much simpler way to express the same quantity. Can you tell I'm channeling Panera right now? I don't know. Let's just stay with it. So if you look below, let's do another example. Let's name these quantities. 3, 4, 5. 1, 2, 3. 2, 4, 6. All right. So now that we've named all of our fractions that have been shaded based off of how the wholes have been divided, we notice it's the same quantity in all of them. What is the most simple way to express that quantity out of all of these? Well, that would be 2/5. Simplest form is using the smallest numbers possible to express a quantity. This next one's my favorite. Let's come down here. Let's name all of the quantities. So we have 8 out of 8 are shaded. 5 out of 5. And 1 out of 1, or just 1. Notice the whole thing shaded in every single square. So if you are looking at this and somebody asks you, hey, you think you're going to eat just half that sandwich? And you're like, oh no, I'm going to eat 8 out of 8 of my sandwich. You wouldn't say that. You're like, no, I'm going to eat the entire sandwich. I want one whole sandwich. So what simplest form? Over here, 1 out of 1 or 1. Excellent. It's the smallest and most simple way to express a quantity. If you look below at these examples, you might notice that we're moving away from pictures. All right, so now in these examples, they say in a group of equal fractions, the circle the fraction that is in simplest form. So it's getting us to understand and remember that simplest form is using the smallest numbers possible to represent the same exact quantity. So let's look here. Which one is the smallest numbers possible to represent the same exact quantity? 1 out of 3. 1 out of 3 is a lot easier to picture in your mind than 7 out of 21. Let's skip down to a different example. Let's come down to the bottom corner over here. Should we do 3 out of 21, 4 28s, 10 out of 70, or 1 out of 7? What's the easiest to imagine? 1 out of 7, smallest numbers possible to represent the same quantity. Well, now that we know what simplest form is, how do we get there? How do we express it? Let's keep going. Before we really dive into that, I also wanted to mention simplify or reduce. You are going to see these words often, whether depending on different worksheets or textbooks or teachers that you have. To simplify or to reduce means the same exact thing. You will often hear the directions of the teacher includes the words to lowest terms. So you may hear simplify to lowest terms or reduce to lowest terms. Or just to be super confusing, you might not hear them say to lowest terms. They'll just say simplify your fractions or reduce your fractions. But I wanted you to know that the words simplify and reduce mean the same exact thing. So let's practice simplifying. How do you get there? Well, it's exactly like how you got to your equivalent fraction on our first page, but it's kind of like going backwards. So let's take a look at what I could be talking about. Find the greatest common factor, or the GCF, of the numerator and denominator. Let's take a look. Let's write out the factors of 6. I know I have 1 and 6, 2 and 3, and nothing else. Draw a little line, stay organized. Then I have for 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Can I fit it? Barely got it. So what is the greatest factor that can fit into both? 6s. Since 6 is the greatest factor that can fit inside, evenly divide into both of those numbers, we're going to divide top and bottom by 6. So let's come down here and see what happens. Divide both the numerator and the denominator by the greatest common factor. All right, so we're going to do divide it by 6 over 6. 6 divided by 6 is 1. 24 divided by 6 is 4. And 1/4 is an equivalent fraction to 6/24, but it's in simplest form. Now notice I drew a blue 1 around 6 over 6 because I wanted to remind us of something really important. It says dividing by 1 does not change the quantity of your fraction represents. It just changes the name. So remember our pictures. If I had a picture of 6/24 shaded in, and I also had a picture of 1/4 shaded in, it would be the same exact quantity. We just would have divided that rectangle into different amounts, but 1/4 is a much bigger piece than 1/24. So it takes 6 of them to make the same quantity. So come down here. It says the answer will result in an equivalent fraction to your original problem. 6/24 equals 1/4. So in previous grades, you've kind of gone the different direction. You've seen something like this. You've seen 1/4. So instead of multiplying to create a larger equivalent fraction, we are dividing to create a more simple fraction. Now, some of us might not reduce by the greatest common factor the first try. And so you might actually reduce by dividing top and bottom by the same quantity, but you didn't get to lowest terms. I want to do an example of that because that's okay. You just always have to check your numerator and denominator to make sure there's no more common factors you can divide by. So let's see what it says. It says you can take more than one try if you need or if you like to. For example, 20 out of 30. Let's think about what would the greatest common factor be. Well, I can see they both end in a 10. Or in a 0, and that tells me by my divisibility rules that they can both be divided by 10. So if I divide my numerator and denominator by 10, let's see where I get. I get 2 thirds, and always check. 2 and 3, any more common factors? Nope, that is lowest terms, because 20 over 30 is equivalent to 2 thirds, but 2 thirds is much more simple. But there may be times where maybe you don't notice or you don't guess the greatest common factor in the first try. So I wanted to show you an example of that. What would happen if you didn't choose to start with 10? What if you were like, I want to start with 2? And that happens to a lot of kids. They just like to start with 2 to get the numbers lower until they get to smaller numbers that they're more comfortable with their division facts. So let's divide by 2 over 2. They're both even. We can do that. 20 divided by 2 over 2 is 10 over 15. And then all of a sudden you might say, my divisibility rules show me a 0 and a 5. I know that 5 can go into that. So let's divide top and bottom by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Do 2 and 3 have any other common factors? They don't. It's lowest terms. Did we get the same answer in top and bottom? Yes, we did. So what's the advantage to thinking a little bit harder before you divide to make sure you have the greatest common factor? Well, basically, it just saves you some time. But if it's harder for you to find the greatest common factor than it would be to just divide a couple times to get your numerator and denominator to smaller numbers so you're more comfortable, it doesn't matter. So your goal is to try to find the greatest common factor, and if you can't, work with whatever common factor you know. All right, guys, hopefully this was helpful. I hope you understand how simplifying fractions work. Have a great night.